Okay, here's another review video for my students studying logic gates, and we're just going to run through the logic gates you should know by this point. So what's this logic gate? Well, hopefully you know by now the triangle with a circle is known as a NOT gate, and the NOT gate will simply invert the input. So in this case the input is called A and the output's Q. So if we have 0 in, we'll have 1 out, and 1 in will have 0 out. If you're asked in a test to write this algebraically, you're going to say the output Q is equal to not A, like that. Okay, hopefully that one's quite simple. Look at a couple more. So if you see this one, hopefully you'll be able to identify this one. I sometimes say to people, it looks a little bit like a capital D, so you might think of AND like that. Maybe that doesn't help you, but this is a logical AND, so that's an AND gate. And with the AND gate, you hopefully do know that the output Q will be true when A and B are true. In all other situations, the output Q will be false or low. If you are asked to write this algebraically, you're going to say the output Q is equal to A dot B, and we read that as A and B. I think in a previous video, or in another video anyway, I've mentioned that it's a little bit like a multiplication. Okay, let's look at another one then. This one, I sometimes say to people, I don't know whether this helps, comes from the planet OR. It looks a little bit starshipy, doesn't it? So this is from the planet OR. So it's an OR gate, a logical OR gate. Now with the logical OR gate, the output will be true if A is true or B is true, or even A or B are true together, because this is also known as an inclusive OR. So we can have everyone, it's inclusive. So let's complete the truth table when none of the inputs are true, so the output's going to be false, but in all other situations we've got at least one, and in the last final case here we've got both inputs being true. So that's the completed truth table. If you're going to draw the symbol, if you're asked to draw the symbol for this, sorry, not the symbol, we've already got the symbol. If you're asked to write this algebraically, you're going to say that Q equals A or B. So although it has got the plus symbol, we always read this as OR. Okay, let's look at another one then. So this one looks like an AND, doesn't it, with a capital D. However, it's got the small circle, which appeared also in the NOT gate. So it's like an AND and then knotted. In other words, it's a NAND gate. So with a NAND gate, we have the reversal of an AND gate, because it's an AND and then we knot it. So with an AND gate, if you have both the inputs true, the output will be true, but we're going to flip the logic. So the completed truth table is like this, because it's the reversal of an AND gate. And if you were asked to write the algebraic statement for an AND gate, then assuming that your output is Q and your inputs are A and B, we would then write Q equals A and B knotted, and we would read this, if you were saying this to someone, you would say A NAND B. And don't forget, this is all equivalent to A, B, that's an AND gate, isn't it? And then that then goes through an inverter, a NOT gate, like that, leaving us with the output Q. If you want to do this step by step, we would then say A and B, and then here it's going to be A and B knotted. Okay, let's look at another one. This time around, what have we got? We've got Well, it looks like an OR gate. It looks like that starship from the planet OR, doesn't it? But then it goes through a negation. We've got the circle there. So in other words, it's a NOR gate. Now, with a NOR gate, it's a little bit like a neither or a none of gate. What that means is that if none of the inputs are true, neither this one nor the other one, then the output will be true. But in all other situations, the output will be false. If you're asked to write this algebraically, you're going to write Q equals A or B, but because it's a NOR gate, we're going to have to invert the output, just like we did with the NAND gate. If you want, just for completeness of this explanation, let's just do the two inputs A and B, or rather A or B, because we're going to go into an OR gate like that, which then gives us A or B, and we take that, pass that through a NOT gate, which will then give us A or B knotted. So that is the algebraic equivalent. That's the algebraic statement for a NOR gate with the output Q. Slightly off screen there, I think, wasn't it? Okay. Right. Let's see if we can identify this. Well, this one should be really easy if you're asked this. There's only one input and then one output, but they all have one output, but only one input, so it's got to be a NOT gate. What do we got here? Well, the output's true only when A and B are true. Oh, in other words, it's an AND gate. Now, remember, you should be able to draw the symbol for that. If you think that you can't, then you need to practice it. What do we got here then? Well, A is true, the output's true. B is true, the output's true. A and B are true, the output's true. In other words, it's an inclusive OR gate, isn't it? Well, it doesn't actually say inclusive OR, it's just an OR gate here. That's good enough. We don't learn in GCSE about the exclusive OR gate, so don't worry about that one. Okay, what have we got now? Well, none of the inputs true, the output's true. Just one of the inputs true, the output's true. Just the other input is true, the output's true. But when they're both true, the output's false. In other words, it's the reversal of an AND gate. So it must be a NAND gate. We're getting there. Last one now, I think. Okay. Do you recognise that one? I'll give you a moment to think about it. You can always pause, of course. Well, hopefully you have realised it's when not the input of A and not the input of B being true. So in other words, neither of them or none of them or nor of them, if you could say such a thing in English. So it's a NOR gate. Okay. And that's it. Hopefully you are now able to identify all the gates, the symbols for the gates. You're also able to draw those gates given a truth table. You're also able to, if you are given a truth table, identify which gate is, what else, write them algebraically. If you can do all that, then you're probably okay, or at least on the way to getting sufficient knowledge for the test. Okay, good luck.